Flux core arc welding on pipe. This is the welding 3, module 3 of your NCCER welding curriculum. I'm going to go ahead and skip past this. I'm going to let you can pause your YouTube video here if you want to read through your objectives. And you can pause your YouTube video here if you want to read through your performance profile tasks out in the shop. Going to get on into it. Flux core, we've got the two versions here, right? Up top, we've got a nozzle on here. So this is the gas shielded flux core. We run a dual shield, so we're running, we're getting protection from the flux on the inside. We're also getting a 75-25 gas shield around there, so that makes for a really slick bead. Down here, we've got the self-shielded version, so it's a naked tip, no nozzle, because we're not flowing or funneling any shield gas towards our weld pool. Flux core arc welding contains flux, which degasses the weld. And by degas, what are we talking about? Essentially, it's just pushing away the regular atmosphere that you've got going on. So typically speaking, we got 77% nitrogen, 20% oxygen, and the rest inert gases are floating or bouncing around. But we're trying to protect that and control the environment in which that weld is formed and in which it cools. So we've got flux inside our flux core wire that allows that to happen. Earplugs. So we've got a public safety announcement here in the middle of our flux core pipe lesson on safety. Earplugs can be worn even when decibel level isn't an issue, and we should put those in at 85, if you'll remember, 85 decibels. But some welders put them in just to prevent sparks from getting down in your ear, and you think that's crazy until the first time you catch a spark down the ear, and then you'll understand. I'm right-handed. Typically, I want to rock my head a little bit to the right, so I wear my beanie to cover my left ear for just such an occasion. But you can put earplugs in too if you want. Flux core arc welding application and filler metal determine the polarity of gun and the workpiece leads. So what we're saying here, the filler metal will dictate the polarity. That should not be foreign to us, because a 6010 is a filler metal, and it tells us exactly which polarity, DC positive, we'll be using. All right. Same thing goes on the flux core. Your flux core arc welding wire is going to dictate the polarity that you're using. Now we use a dual shield, so we're still on DC positive. But old school wise, it was common to switch out to a DC negative to run your flux. Higher welding heat, deeper penetration, and higher beads result in higher amperage. Result from higher amperage. So we turn that up. We turn wire feed. That's how we're controlling amperage, is the wire feed. And if we turn the wire feed up, then we're going to have to turn voltage up, which gives us our heat. The higher the heat, the deeper the penetration, and the more the wire, the more the bead is going to build up. So all that should make sense. Higher wire feed speed, higher voltage, deeper penetrating, wider, just overall bigger, larger beads. Flux core is set up, requires voltage set so that the arc length is just above the surface of the base metal. So there's your arc length, and you're not going to be able to tell much, I guess. It might be a quarter inch, maybe eighth, maybe much like what your 6010, 7018 is. But yes, it's set to that solid is going to come out, and that electric is going to be such that the heat melts the electrode and it spits onto your base metal. So the voltage that gives, what voltage do we want? Enough to where we are burning that electrode up, that 045, just before it hits the base metal. So it's entering or touching the base metal in its liquid state. Flux core 045 wire, electrode extension, and I'll back up here. The electrode extension, this is a better picture for that, is how far the electrode is sticking out from the contact tip. So from your tip, you start the measurement, and before the arc length changes it to liquid, that electrode extension needs to be 3/4 to 1.25 inches on your flux core arc welding. 3/4 to 1.25 inches. All right, the pipe's axis determines the position of a groove weld. So typically on plate welding, the plate's axis dictates what we're welding. But notice here, so the pipe is in the horizontal here. So that's going to be pipe horizontal. We're in the 5G. Because this one's rotating, we're going to stay on top and be in the 1G. Here the pipe's axis is vertical, and that's going to tell us that we are welding in the 2G. We're going to come around this one to weld. And your pipe's axis inclined at a 45-degree angle tells us we are in the 6G welding position. So your pipe axis determines the position of a groove weld. Inside diameter of pipe will be reduced and flow restricted if the root pass has excessive root reinforcement. What are we saying? You can't put big old heavy fat roots in these welds because what area of a circle pi r squared, you are drastically reducing the effective flow that we can put through a pipe by adding fat roots, and that is obviously exponentially important the smaller the pipe gets. The smaller the pipe gets, the more impact a heavy root has on it. So depending on what you got going on, food grade stainless especially, they want a slick root, and that's for different reasons altogether. It's not because of the flow necessarily, but because they don't want milk or something getting backed up in a clumpy root that's going to cause it to cause it to rot or back up with mold and stuff in that root. Root reinforcement on pipe should not exceed 1/8 inch. And that's straight out of the ASME code book there. So that's what we're looking for, an 1/8 inch on top, 1/8 inch on bottom. And all we're really looking for is break down that wall, but that wetting band sure is pretty. We've talked these in earlier units, overlap. Essentially that's going to cause a harsh roll and a tie into that toe. So stress riser, just like your excessive reinforcement, plus you're not doing anything. You didn't fuse into your base metal. Undercut, what do you need to do to fix that? Slow down. If you slow down, your filler metal will fill that in. And underfill, you just didn't cap it. I mean, on the root, you didn't break through. Your QC probably should have pulled you off this coupon when you didn't get through on the backside, to be honest with you. 1G rotated position requires the workpiece clamp to be attached to the pipe coupon. What we're saying is we don't want you passing electricity through everything. So you wouldn't want to clamp down here to the bracket holding the tire, because there's bearings in this rotating piece and all this other stuff up here. These are rollers, they're bearings up there. You're going to pass electric through all that and end up burning something up. So put your clamp as close to you as possible. That's going to help you out anyway. You get a better arc with your better ground. If workpiece is not directly attached to a coupon, arcing between the pipe and the coupons and the roller supports can happen, and that is true. So you're going to see little arcs, jumping across as that electricity is trying to find home. Again, just bring it closer to you. And if that's happening, you're not getting a good arc off your process. So just bring that ground a little closer to you, and everything will be a whole lot better off. FCAW 2G gun. So in the horizontal, and that's the position we're looking at right here, your 2G gun should have a drag angle of 10 to 20 degrees. 10 to 20 degrees. 5G are secured with a pipe axis horizontal. We talked that a minute ago on what the pipe axis should be. The 5G is actually called a bell hole too, so you can call this a bell hole if you'd like. And the 6G is the Arkansas bell hole. 6G position can vary plus or minus 5 degrees from the 45-degree angle. We're just going to use a torpedo level and make sure our bubble is between those two black lines, and we'll call that good for your 6G welding position. Angle iron is used to align the pipe coupons, especially in smaller diameter pipe. Every one of your KWI booths has a piece of angle iron next to the table. You're going to roll those two pieces of 6 or 2 inch down in there, and then start your fit. Okay, and that's going to take a lot of the high-low out of the equation. That's FCAW Module 3 of Welding 3 in the NCCR welding curriculum.